Okay, so here we have, what is this shape?
This is a tetrahedron.
All right, what do you think is going to happen when we dip this in?
So it's kind of like what happens with the cube, except that they just meet at a point in the middle.
All right, put it in. Okay. Lower it about an inch. There we go. All right, so tell me about what you see here.
So this is, we have sort of the altitudes to the opposite faces from each vertice, and they meet at this point in the middle.
All right. What do you see?
Well, if you sort of look at it from one side, I sort of see the angle bisectors of this triangle side.
Oh, wow, the angle bisectors.
Yeah.
Okay. What would that mean about that point, do you think?
So it would be the center of the tetrahedron, or the face, too.
What do you mean?
It would be the center, like the center of the tetrahedron.
Interesting. Okay. Do you think this shape has any four-dimensional implications like the hypercube one did?
Well, this here is a four-dimensional tetrahedron.
Okay.
This is what the 5-cell. I think it just popped.
Yeah.
Oh, well.
Here, re-dip it.
This is what the 5-cell actually looks like.
So this is what the 5-cell looks like. How do you think you could describe the 5-cell?
So it's composed of 5 tetrahedrons.
Mm-hmm.
But the 4 of them are squished. You can make the tetrahedrons by using the center thing made by the bubbles and 3 vertices.
Huh.
And the 4th is just the tetrahedron made out of greens.
Well, to make like the cube, first you take a point and slide it and you get a line, then you take the line and slide it, you get a square, you take the square and slide it, you get a cube, take the cube and slide it, you get a hypercube. How do you, what's the analogy? What's going on in the same way with the tetrahedron? What do you think?
Well, I mean, instead of sliding, like to get from a line to a triangle, you're going to slide it up, but you're also going to shrink it as you do.
Ah, interesting. Okay.
So the 2 points at the end become 1 point.
And how about to go from the triangle to the tetrahedron?
Now it's kind of the same thing. The triangle slides up, it shrinks until the 3 vertices become 1 point.
Okay.
And maybe the same thing is going to happen here. You slide in some direction, so these 4 vertices become 1.
What do you think?
Yeah, I think in this case you're going to slide in to meet, the vertices might slide in to meet at that point.
All right. Can you see what happens if you do the same, try to capture a bubble with this? Did you get one?
Yeah.
Is that on the inside?
Big.
Yeah. It just sort of gravitated to one side.
Interesting. What does that look like? What does that bubble look like?
Well, if you spin it this way, it sort of has one triangular face, but the rest are sort of distorted.
Oh, I wonder if I'll pop it down there. No, try again.
Cool. Oh, there we go.
So now we actually
Okay, just had to
have
be
a
small enough.
tetrahedron.
You have a tetrahedron in the middle. Is that a perfect tetrahedron?
Yeah.
Except for the fact that the edges are sort of rounded.
It's like you sort of took a tetrahedron and inflated it a bit.
Okay, cool. All right, now we're going to go on to 2 shapes we have not done before.
Alright.